Pooja here from Platform9. I'm the engineering lead for the private cloud director product here, and it's my pleasure to kind of walk you through the core features of the platform. So I'll get right into it. So the main motivation behind the private cloud director product has been how do we simplify the whole private cloud experience for users who may be coming from like a public cloud background and the ease of use that comes with it, and be able to kind of reduce the administrative burden that comes with managing your own private data centers. So that was the core motivation, and in achieving that, what we introduced is what called a cluster blueprint. So before I get into that, let me talk a bit about what is a cluster. So those of you who are familiar with VMware, you already know that there's a resource kind of aggregation that happens at a cluster level, and it's basically a set of hypervisors. So that's what a cluster is. It's basically a homogeneous set of co-located hosts. And this could be based on geography. You can have different clusters that are set up, and you can manage them via a single cloud platform. The assumption here is also that you have kind of a similar networking layout across these hosts. So you may be running with a certain physical networking layout, and all of these hosts kind of have that same kind of interface mappings. When I get into the demo part, I'll show a little more about what kinds of blueprints we offer. Another aspect of provisioning a virtual machine is you may want to target it based on certain hardware or performance characteristics of your hypervisor. So that is what is kind of allowed by the concept of host aggregates, which is basically a administrative way of defining what software or hardware characteristics may be available for a specific hypervisor. And this is completely user-defined. So I'll show that as well as we get into the demo. So in terms of the hypervisors here, for the virtualization technology, we're using KVM as the underlying hypervisor, which uses the QEMU hardware emulator. So this is kind of an industry-tested virtualization platform, and it's also used at scale by major public cloud providers. So this is something we have running with customers at scale of about 10,000 nodes across geographical locations. When we have to kind of provision virtual machines on your hypervisor, you want to make sure that you're utilizing the resources very well in your data center. And sometimes you may have workloads that may be running at various peak times. You may have different kind of load on the machines. So you want to make sure that you make the best utilization of your hardware in that case, right? So in KVM, you have this option that you can overcommit or over-provision your resources. So for example, let's say I have a bare metal machine which has 32 cores, and I want to run 100 virtual machines that are going to run with 8 CPUs, but all of them may not be utilizing the whole 8 cores at every single point in time. So the over-provisioning kind of feature lets you do that, and it will automatically balance the virtual machines based on what kind of load you have on that hypervisor. Once you have the hosts onboarded on your private cloud platform, there are certain day two kind of features that you would expect from that environment, right? So let's say there is a critical CV fix that is required to be patched on your hypervisor nodes. Now, how do you do that without really impacting any of the workloads that are running in your environment, right? So that is one case where you may want to have minimal downtime for your applications. So you want to migrate off any workloads while they are running. So that's the live migration capability that you would need. And the second use case might be that you have live migration, but that's more of when you have planned for certain downtime, and it's a maintenance activity that's been scheduled at a specific duration, right? But what happens if you lose a hard disk on one of the servers, right? So in those cases, you want to have at least some kind of high availability for your machines where you're able to evacuate that host by moving off or cold migrating some of the virtual machines that are running on that failed node and distribute it across the rest of the nodes in your system. So I'll talk more about that in the next section. But let's get right into the demo part. So When you get into the UI, I'm currently logged in as an administrator here. So on the left side, you'll see a pane of options here, which kind of shows you the infrastructure view, the virtual machines, and different constructs that I'll dive deep into as we go along in the session. But on the right here, you can see the user that you're logged in as. There's a concept of multiple regions, which again, I'll cover later in the slides. And then you also have a drop-down here for selecting what tenant you belong to. So I'm currently logged into the service tenant. And as you can see, I have 3 hypervisor nodes that are currently enabled here. And if I want to add another host, there is this command that a couple of commands that you need to run on that hypervisor to get it onboarded to the platform. And I'll kind of kick this off and then go back to the blueprint screen so that it gives it some time to get onboarded.
Can I have a question here before we start? So the multi-tenancy is based on the hosts, not on the resource pools.
So the multi-tenancy concept here is kind of when you have a data center, you can think of the physical location as mapping to a region.
Yes.
So you have a region as a cluster of hosts, and within that you can define multiple tenants, which is more of a logical abstraction, right? Which it spans across those hypervisors.
Okay, thank you.
So in that case, does the environment support true multi-tenancy where you have one management where you could have multiple customers, say, and each customer can then log in and they only see their subset of hosts?
Yes, absolutely.
But hosts or resources?
Or hosts?
The resources, yes.
The resources.
Yes.
Okay.
So the host belongs to a region, but then if you are an MSP kind of customer, right, in that case, you may have your own customers. So you want to dedicate one tenant for each customer, and they would only be able to see their own, let's say, their networks or their virtual machine resources, and everything is kind of catered to that single customer and that tenant. But in terms of the underlying hardware, that is shared across that region.
Thank you.
Any other questions before I move into the demo part?
We are going to be demoing that in a second as well.
So this is a Ubuntu host that I've already kind of provisioned. I'm just going to try and add this to the pool as well. So just going over the 2 commands I showed. So there is a CLI that we have for onboarding a new server. So I'm going to just download that here. And then there is this one command, the pf9ctl prep node, that you need to run for onboarding it to a region. Now, this is where you can specify what is the account URL where you're trying to onboard this host. I'm going to give the URL, which is the region 1 in this case. So this is going to run a bunch of prerequisite checks to make sure that it satisfies all the dependencies. For example, that it has virtualization support, or it has all the necessary CPU, memory, and disk prerequisites satisfied. And then it will install some dependency packages as well as part of this command. So this will take about 2 to 3 minutes. So in the meantime, let me go back to the blueprint. So the cluster blueprint, like I said, is where you can define your actual layout of the data center, which is like a common template for all your hosts. We offer 2 flavors of this blueprint, and then there is a custom blueprint, which is a lot more flexible. But let's talk about the server consolidation blueprint. So this is something which is maybe catered more towards simple users, where you have an administrator kind of come in and set up the environment for other users to just come in and start deploying VMs on, right? So for those kind of enterprise customers, or somebody who's coming from a VMware background and doesn't really need a lot of complex networking, they might want to stick with the server consolidation blueprint. And then if you have so I'll show the physical networks is something that you would let the administrator go and configure here, which lets you define what is the kind of physical network that you have. It could be a VLAN-based network, VXLAN, or a flat untagged network. And in addition to that, you can specify some of the parameters which are optional for you to customize, but you could have separate interfaces configured, let's say for your block storage environment or for your images. There could also be some custom hypervisor configuration here where you can say, I want to access my VM console via a public IP versus an internal IP.
Could you go back up a second?
Sure.
You showed NetApp storage, Ceph, and custom center. So you don't support other types of storage, or?
No, we do. So I'll talk more about that in the when I get to the block storage section. But we do support most of the standard storage providers. So in the industry, I think there's like a vSphere storage array integration set of vendors, and then with Cinder you have hundreds of vendors that are supported. So we work with those. And in terms of the web portal here, you're seeing 4 or 5 that have been handpicked, but we plan to add more to this list as we go along. And this is also something that we started with adding this custom backend so that if you have something that is not a very typical or widely used platform, you're still able to work with that and will help you kind of onboard that kind of storage array as well. So these are some of the common settings that you would define in the server consolidation blueprint. And then when I get into the multi-tenant blueprint, in terms of the use case for MSPs, let's say, where you have need for complex networking, you want to define multiple tenants and then have virtual networks or routers configured per tenant. In that case, you would want to opt for a multi-tenant blueprint. In this case, you'll see this in addition to the physical networks that were part of the admin setup in the server consolidation blueprint, you will also see a section here for setting up the virtual networking. Again, I'll reserve the details for the next section when I talk about the SDN capabilities. But at a high level, these are the 2 main differences between these 2 kinds of blueprints. And then the custom blueprint is something that is even more flexible if you have very specific needs. So while we are doing that, let me just go back and check. Okay, so by now the host has completed installing the Platform9 agent. So as part of this, we establish a communication channel back to the control plane that we already have. So if you go into the cluster host section here, now in addition to the 3 already authorized hosts, you should see a 4th one show up here, KVM demo 4, and it shows up as unauthorized. And on the right side here, you would notice the kind of roles that are assigned to these servers. So in the current environment, I have 3 hypervisor nodes, 1 image library node, and 1 block storage node. I'm going to go and authorize this new node as a hypervisor as well. So you can see that once the blueprint is configured, this is a very easy to automate and a repeatable process to kind of bring in new servers and add capacity to your cloud. So I'm going to select the hypervisor role in this case. And what this is going to do in the background is basically install the agents that are required for running your compute agents or your networking agents on this host that you add. And once this completes, you'll see that the node is going to go in this converging state, which means in the background, it is kind of setting up all of these agents on that host. And eventually, it will show up in this OK state with a green button next to it.
I want to interrupt for just a second because I'm a little bit confused. When you deployed this, you were deploying the PCD agents on a host. That host was already running just Linux?
That was just a stock Ubuntu machine here.
So that was just essentially a bare metal machine that you had then booted. You had just put a plain Linux distribution.
Exactly, yes.
And then you've done that.
So all you need is like a bare OS machine. And for this demo environment, I have it set up as a nested environment. So this is a VM currently, but that's all you need. You just need the OS, and then the prep node command will take care of anything that Platform9 needs to be able to run virtual machines.
And then are you able to do all of that through the GUI, or do you actually have to log into the host to do that?
So just the first 2 steps that I showed here, the downloading of that PF9CTL CLI, and then this prep node are the 2 commands that you need to run, because at this point, we don't have access to your machine. But this is something we also have. So the one I showed you is more of an interactive way of adding that host. But we also have an automation-friendly, non-interactive way where you can say that no user prompts, these are the details, this is my account URL, these are my credentials, and this is the region I want to onboard this host to.
Okay.
And then it will take care of all of that in the background.
Yeah, because I imagine you wouldn't want to do this with 10,000 hosts. You don't want to sit there and do this.
Yeah, absolutely, yes.
Yeah. Most of our customers use Ansible to get that done. Our services team have now a custom playbook to just get that done.
That makes sense. Thank you.
Are those available in like open source areas? Like, was it, I think they call it Galaxy, for people to be able to download and run themselves, or?
I don't think it's part of the Galaxy, but I think, I am not 100% sure, it's part of a public repo that we have where we have a bunch of support tools.
Yeah.
That's, I think the challenge there is a lot of times when they're running installs, the silent is what catches it, like putting in the usernames and passwords
Right.
and things. And so,
Yeah. For the sake of the demo, I wanted to show the interactive way so you understand the parameters. But yes, absolutely, there's an Ansible way of doing it. And different customers have different needs. Some use the Ansible framework. Some already have their host automation with bare metal provisioning as well. So they're able to hook into that framework as well.
thank you.
Can you go back to the infrastructure panel on the?
Sure.
So some of these servers are block storage only servers. I mean, well, with hypervisor, I guess.
Yes. So what I showed here, right? So let's say I select all of these. So you would see that when you, so I already onboarded, in the interest of time, the image library and a block storage node with NFS backend in this case. But you can do any combination of these, and hypervisor is something that I've deployed on all of these hosts, but you could have a combination of those. You could also have multiple block storage nodes with different backends if you want to have NFS, LVM, Ceph, NetApp.
So it becomes a front end for the back end block storage. Is that what you're showing here? It becomes a front end for the back end block storage?
Correct.
In this case, it's NFS, and there's block storage behind the server?
Yes. So I already have an NFS server set up in the background that you can configure. And let me just show the blueprint again. Sorry. So here, when you initially set up the blueprint, right? So there are different options based on the backend you choose. So in this case, because I chose NFS, I can say that this is the NFS server I'm using, and this is the NFS share from that. If I use something like NetApp, then it will show you NetApp specific configuration, where you can configure all of these details and connect to your NetApp array.
Okay.
So yeah, I think like after this node is converged, we should be able to see that it's enabled for scheduling at this point, and can go into the next step. So just to kind of summarize what we just saw, right? One was obviously how to set up a cluster blueprint, the major components of that, how easy it is to onboard a new server, and I spoke about how you can create a host aggregates. And the use cases here, like I said, if it's a hardware kind of characteristic like SSD disk versus a normal hard drive, you could configure that via the metadata associated with it. Or you could also have licensing where you have a host that has Oracle licensing versus others that don't. And then if you want to provision a VM on a specific host, you could achieve that via the flavors on that machine.
Are you going to show the provisioning of a VM?
Sorry?
Are you going to show the provisioning of VM?
Yes. So another thing I want to show before we get into that. So when I spoke about the day two operations, right? For the host that you have here, there is an option that you can say, I want to take this node out for maintenance. And in that case, you can cordon the node. And this would enable maintenance mode, essentially saying that you're not going to schedule any new VM workloads on this machine at this point, right? So this is also something that you would want to do. And then for host evacuation, it does take a little bit of time. So to kind of, I'll just show that in towards the end. But for live migration as well, so I have some pre-created VMs here. But once I talk about some of the other components, I'll show you actual VM creation as well. And once you have a VM, you would see there are different options here. And live migration is one that you could use if you want to have any sort of maintenance on that node that you just cordoned.
Do you install any agent inside the VM, like VMware tools?
We don't. Yeah, but there is a cloud in it way if you do want to install anything specifically for, let's say you want to have some Prometheus exporters inside your VMs for any metrics collection. That is an option that you could do via Cloud.net.
But it's not like something that's coming from Platform9.
Correct.
Platform9 agent.
Yeah, not really.
Just to be clear, When you say Cloud Init, are you referring to Cloud Init inside of the image, or are you referring to Platform9 calling to Cloud Init?
No, Platform9, the Cloud Init inside a VM image so that you can supply during the VM creation workflow.
Okay.
Do you support something like a vSAN kind of way of, I don't know, SEP, for example, across the nodes? That you have 4 nodes and you tag the button, make me a block storage, distributed block storage, and create your block storage.
Yes, so if I understand you right, if you already have an existing Ceph cluster with whatever, like let's say 10 OSPs.
You have for like HCI solution, right? So hyper convergence solution, because the customers, like onboard those hosts, it looks cool, and then you want them to be your storage backend, right? Like vSAN is doing, right? Or any other DFS, but is integrated in this solution or not? Something like that.
I can take that.
Sure.
I think to summarize the question, you're asking if we come out with an HCI solution pre-integrated into the product. Today, we don't. We work with our partners. Ceph is a very popular choice. So we work with that. Other customers also use some of the other storage arrays like NetApp or SolidFire.
But like external, right? So nothing in the host, right?
Nothing in the host.
Not like from
yeah, so nothing integrated into the product out of the back.
Yeah. You mentioned multiple times how you can support customers using existing storage investments, particularly pointing out things like NetApp or anything else where it's NFS. Does that mean there's no support for customers who have large investments in fiber channel storage, for example?
That works. We have customers already using that, like 3PAR, and I forgot the recent customer who is, I don't know, I forgot what they're using.
The Pure Storage.
Yeah, so Pure Storage.
Pure Storage is huge. All the old EMC, now Dell platforms out there.
Yep.
Any of those pretty much could be supported.
Yep.
As long as it's just a regular old fiber channel connection.
Correct. Fiber channel, iSCSI, RBD, Ceph, all of them.
Okay.
Do you have the ability on your management to show us anything where managing hosts at scale? So, you show 4 hosts and managing 5, 10, 20 hosts is pretty easy. What happens when you get to the hundreds of thousands of nodes in your environment? Do you have searching, naming, tagging? How does that all work?
Yeah, definitely. So you're asking more in terms of the web portal, right?
Yeah. I mean, a typical admin's going to sit down and say, I need to work on this set of hosts. How do I find those things that I want to manage?
Right. So, just to kind of give you overview of the kind of spectrum that we have with our customers, right? So we have some customers who have like a fairly large number of smaller clusters where they're like 2 to 4 node clusters, but they have like 10,000s of those. And this is specifically for a coffee chain company that we have as a customer. And then for them, these stores are spread out like all across the world, right? But within each store, there are like hardly like 2 or 3 servers that you would be running. So for those kind of customers, then you have hundreds of regions that you may be managing, whereas on the other end of the spectrum, you may have a customer we have is a networking company who basically has very few clusters, but each cluster is about 200 nodes, and they're both able to kind of use the platform at that scale, depending on their needs. And we have these search capabilities in our UI that kind of allows you to filter through based on certain, let's say for VMs, you can associate certain metadata with that. And once you have that metadata, you could filter based on some key value pairs and take an action on that. We are also able to like bulk select VMs and then perform operations on those if you want to do it at scale. And then similarly for hosts, I spoke about host aggregates earlier, right? So in this case, I have 2 aggregates defined. One has all 3 nodes, and then I've created like a sample aggregate with just 1 node. So the use case could be I'm troubleshooting something on one hypervisor, or I want to run VMs on that node, particularly for, let's say, Oracle license. I can isolate that host on 1 node. And then again, for host aggregates, I can have similar metadata. Like I have here licensing Oracle, and then I can search by that and work on that specific set of hypervisors. Any further questions before I move to the next section?
And you've got host aggregates, but you also have server groups. The server groups would be on a VM basis, so it would be effectively a class or a group of VMs there?
Yes, so with server groups, it is a group of VMs, and then we have support for both affinity and anti-affinity policies depending on your application's requirement. You may want to host all the VMs in that server group on the same node, or have them on mutually exclusive hosts, right? So we offer both of those.
Do you offer like storage policy management, things of that nature, where VMs could be allocated based on their storage requirements?
Yes, definitely we do. And that's kind of, I'll talk about that in the block storage section, but you can associate specific storage backends for a set of VMs.